Hello dear students, I welcome you to this lecture number 12. It is on linear differential equation with constant coefficients. Before this we have reached up to lecture number 11. Up to lecture number 11 we have given you the 4 rules or the 4 types of finding out the particular integral. Now I will discuss the fifth rule. Fifth rule is this. This is a rule or type fifth for finding out particular integral. Suppose you have differential equation of this type. It is xv. What is this v? Where v is any function of x. V is any function of x. It may be sine x, it may be cos x, it may be some other function, but it is very important that this x should be here linear. If it is not linear, then we will switch on the previous rule, that is rule number 4th. We can do it by rule number 4th. Now how to find out the particular integral in this case? You will remember this. In this case, particular integral is found as 1 by f of d. This is your xv. I again remind you that this x independent variable should be here in the linear form. If it is not linear, if it is quadratic, cubic, and if we go by this method, it will be a lengthy one. And for that, suppose it is x square cos x. I will go to the type 4th. I will share one or more one or two examples on that. When this x is not linear, that is when the product of two, you are dealing with the product of two functions. One is x not linear and some other v is some other function of x. Here x, I stress on this, it should be linear. How we find out the particular integral in this case? You see how it is. Particular integral in this case we find, you take this x out. x का काम चला गया बाहर, x के साथ कोई ऑपरेटर नहीं होगा. Then it is 1 by f of d into v, whatever v is. First part is this. Then plus you find differentiation of 1 by f of d with respect to d into v. Note this, it is not the derivative of denominator as you did in case of failure case. Perhaps that was the rule number or this rule or type second it was this. When you differentiated only denominator, it is not the derivative of denominator only, it is here derivative of 1 by fd with respect to d. Whatever you get there, then you operate it with v. This is the particular integral in this case when you have the right side xv, where x is linear independent variable and v is any function of x. You will remember this rule. This is rule number 5th for finding out this particular integral. We may say that it is the last rule, but I have told you in case of this is not linear. Suppose it is x square cos 2x, x cube sin x. How we deal those questions, we switch to rule number 4th back for those. But here when it is this 5, this form, it becomes very simple. Although you can do this very question also, questions of this type also you can do with the help of rule number 4th. You can do them with rule number 4th, but I think in certain cases this rule becomes very easy. I want to share 2 or 3 questions on this. Let us do these questions so that you will understand how to apply these. This is the application of this rule. This is rule number 5th application. It is the application of rule 5th. I will say it is application of rule 5th for finding out what? Particular integral. Suppose I have to solve the differential equation. It is d square minus 1y. It is x sin x. First of all, you have auxiliary equation here, which is d square minus 1 is equal to 0. This gives, as usual, d square equal to 1. This gives d plus minus 1, two real and different roots. Therefore, you can write here complementary function. What is complementary function? It is c1 corresponding to this d is equal to 1 e raised power 1 into x, then plus c2 e raised power minus 1 x. Therefore, complementary function you have got c1 e raised to power x, do you follow, plus c2 e raised power minus x. This is your complementary function. Now we go for particular integral. You see how we find out particular integral. It is x sin x by f of d. What is your f of d? It is d square minus 1. Be cautious now. It is of the form xv, x linear. This v can be any function. Here it is, the v is the function of sin x. How we go? I will just write that rule again. When you have xv by f of d, what is this? X out, 1 by f of d v, then plus differentiation of 1 by f of d with respect to d into v. This is the rule. This rule we want to do here. Similarly, you have this x out, this x goes out. Okay, this is sin x by d square minus 1, 1 by f of dv, then plus differentiation of 1 upon d square minus 1 with respect to d into v. What is your v? It is sin x. Do you follow? Now, this is your particular integral x. How you do here? The sin x, coefficient of x here, it is 1. It is replaced by minus 1 square. Previous method, rule number second, sin x by minus 1 square minus 1. Then plus, you have to differentiate this. How you differentiate this with respect to d? You take this in the numerator. It is d square minus 1 raised power minus 1 sin x. Now it is particular integral is here. It is defined here. It is x sin x by minus 2. Then how you differentiate this? Minus 1 down. This is d square minus 1 raised power minus 2. Internal derivative of this, it is 2d sin x. Then it is equal to minus x by 2 sin x minus 2d by d square minus 1 whole square. It is sin x. Let me come here. Well, this is your particular integral. Your particular integral comes out to be, particular integral is minus x by sin x minus x by 2, sorry, it is minus x by 2. It is minus x by 2 sin x, then minus 2d by d square minus 1 square sin x. Now this d square is replaced by this coefficient of x minus 1 square by the previous formula, previous rules, minus x by 2 sin x minus 2d by minus 1 square minus 1 whole square. It is sin x, so it is minus x by 2 sin x. It is minus 2 whole square, it is 2 by 4, then d of sin x. Do you follow? D of sin x means derivative of sin x. This gives you particular integral is minus x by 2 sin x minus derivative of sin x is simply cos x. It is minus 1 by 2 cos x. This is your particular integral. Very simple in this case. So what is the complete solution? So your complete solution is y equal to complementary function plus particular integral. Yes, what is your particular integral now? Complementary function, it is y equal to c1 e raised power x, this is complementary function, plus c2 e raised power minus x. Then particular integral you found minus x by 2, it is sin x, then minus 1 by 2 cos x. This is the solution of such questions when you come across the questions like when right side is x into some function of say x sin x, x cos x, so on. Let me have one more question here, one more application. Suppose we want to solve the differential equation. It is d square plus 3d plus 2y is equal to x e raised power x sin x. These are three functions. Exponential function is involved, e raised power x is involved, sin x is involved. You sometimes come across the questions like this. How you do it? First of all, you will write auxiliary equation. What is auxiliary equation? It is d square plus 3d plus 2 is equal to 0. You solve it. It gives d is equal to minus 3 plus minus under root of 9 minus 8 by 2. This gives d is equal to minus 3 plus minus 1 by 2. That is d is equal to minus 3 plus 1, it is minus 1, and it is minus 2, minus 4 by 2. This is the value of d. Therefore, here you have corresponding to these two values of d, you have complementary function. What is this? c1 e raised power minus x plus c2 e raised power minus 2x. This is the complementary function. Now it is very important how we find out particular integral. Now we find out particular integral of this question. It is x e raised power x sin x by d square plus 3d plus 2. You see, it involves the exponential function, it involves x. Actually, it is a product of three functions. You see how we deal with this. I will write this very important setup: e raised power x sin x by d square plus 3d plus 2. Let me put, for the time being, let us put x is equal to x sin x. I am replacing this x sin x by x for the time being. What is this now? This particular integral comes out to be e raised to power x into x by d square plus 3d plus 2. Now apply here rule fourth. What does rule fourth state? When you have one function exponential and second function is any function of x, one is necessarily exponential. When it is exponential, how we evaluate the particular integral? This e raised power x goes out. इसका काम अब कुछ नहीं है, ये बाहर जाता है, और आपको देखना है x का कोफिशिएंट क्या है यहाँ पे एक्सपोनेंशियल में. एक्सपोनेंशियल e raised power x, the coefficient of x is 1, and this d will get increased by 1. How? It is 1 by d plus 1 whole square plus 3 d plus 1 plus 2 into this x. That is, this is operating upon this x. Be cautious now, because how we add this one? It is rule number fourth, because of exponential function. Well, this is e raised to power x out. This I will write x by this x by it is d square now, d square plus 1 plus 2d plus 3d plus 3 plus 2. Let us see what it is now. I will rub it. This is my particular integral now. Particular integral is e raised power x out x by d square plus 3d plus 2d plus 5d plus 3 plus 2 plus 1 plus 6. I have to find out now particular integral for this. I will go this way. I will write pi is equal to e raised power x into I1. Let us name this alpha, equation alpha. I will find out I1 now separate. How we find out I1? I will find out I1 by rule number 5th. Rule number 5th I will apply here now. You see how I find out I1. Be cautious. My I1 is now, I1 is also particular integral of this part, x by d square plus 5d plus 6. What was our x? It was x sine x. X sine x by d square plus 5d plus 6. How we go? It is rule number 5th now. For this particular integral, this part, it is converted into rule number 5th. When you have linear x and this is v, any function of x. Now how you do? Take this x out. This is x out into 1 by d square plus 5d plus 6 v. What is your v? Sine x. Then plus differentiation of 1 by fd, 1 by d square plus 5d plus 6 with respect to d into v. What is v? It is sine x. Be cautious. Now I will differentiate this separate here. What is the derivative of this? You see, differentiation of, I will write it here, differentiation of 1 by d square plus 5d plus 6 with respect to d means differentiation with respect to d of d square plus 5d plus 6 raised power minus 1. This is minus 1 down, then d square plus 5d plus 6 raised power minus 2, internal derivative is 2d plus 5. So this is your minus 2d plus 5 by d square plus 5d plus 6 whole square. It is the derivative of this. Derivative of 1 by d square plus 5d plus 6 with respect to d. It is minus 2d plus 5 by d square plus 5d plus 6 square. Well, this I will write I x. I stands for particular integral for this part. Then I will use it in alpha. Be cautious. Now here d square is replaced by sine. Coefficient of sine, coefficient of x in the angle is 1. So it is 1 by minus 1 square plus 5d plus 6. This is sine x. Then this is your derivative of this is minus 2d plus 5 by, it is d square plus 5d plus 6 whole square into sine x. Now how we go? It is I is x sine x by 5d plus 5. Now here it is minus 2d plus 5 by, I have to replace d square by this minus 1, minus 1 square plus 5d plus 6 square into sine x. Do you follow? This is rule number 2nd or 3rd, where we have sine x by fd square. D square is replaced by minus a square. It is that rule. Well, my alpha is, I will write it here, my alpha is particular integral is equal to e raised power x into I1. This is my alpha. I am finding at this time I1. I am finding out I1. I1 I am finding out. I will drop it. I don't need it now. Now this will be I1 is x by 5 sine x by d plus 1. I took 5 here common. Well, this is minus 2d plus 5 by, it is 5d plus 5 square sine x. I am simplifying this, be with me. Now here I need d square because of sign here. How we do it? It is x by 5 sine x by d plus 1, rationalize d minus 1 by d minus 1. Do you remember? Because when we have the linear factor in case of sine or cos in the denominator, we rationalize it to get denominator d square. It is this. Now it is minus 2d plus 5 sine x. This is your, take 5 common, it is 5 square 25. Then it is d plus 1 whole square. It will be d square plus 1 plus 2d. When you take 5 common, 5 square is 25. Then it remains d plus 1 square. That is d square plus 1 plus 2d. Well, this is I1 is x by 5. It is sine x d minus 1. Then it is d square minus 1 here. Just look here what is here. This is your minus 2d plus 5 sine x by 25. We have to replace this d square by minus 1 square, coefficient of x in the angle. It is minus 1 square plus 1 plus 2d. Minus 1 square plus 1 plus 2d. Now just look what is this now. It is I1 is x by 5. This is sine x d minus 1 by minus 1 square minus 1 here. This is minus 1 by 25. It is 2d plus 5 sine x. What is this now? Minus 1 square plus 1. It is minus 1 plus 1. It is only 2d. Very important step. This is I1 is, it is minus 2. It will be minus x by 10. Then sine x d minus 1. Then it is minus 1 by 50. 2d by d plus 5 by d sine x. Just look what I did here. I took this 2, it is 1 by 50, then 2d by d is here, then 5 by d is here, operating sine x. Now what is this now? It is I1 is minus x by 10 d of sine x. When you operate, take this left side, d of sine x, derivative of sine x, it is cos x minus sine x. Then minus 1 by 50, it is dd cancel, it is 2 plus 5 by d of sine x. Just see now I1. We are concluding this now. It is now concluded. So I1 comes out to be, your I1 is minus x by 10. It is cos x minus sine x. Then take sine x, minus 1 by 50 twice sine x plus 5 times integral of sine x. Why? Why integral of sine? Because it is operating 1 by d of sine x. When you take sine x here, twice sine x, then 5 1 by d of sine x. 1 by d of sine x means integral of sine x. So it is I1 is minus x by 10. This is cos x minus sine x. This is minus 1 by 50. This is your twice sine x. Integral of sine is minus 5 cos x. Therefore, you get I1 is minus x by 10 cos x minus sine x minus 1 by 25. It is minus 1 by 25 sine x. Then it is plus, yes, 1 by 10 cos x. Using in alpha, you will have the particular integral of the required question. So required particular integral, using in alpha a required particular integral is, when you use it in alpha, it is e raised to power x times this minus x by 10 cos x minus sin x, then minus 1 by 25 sin x plus 1 by 10 cos x. I think you have followed this. This was a bit some typical question I have touched here, so that you are in a position to do other questions easily. So what is the solution? So required solution, hence required solution is y equal to complementary function plus particular integral, as usual. What is your complementary function? It is this. This was your complementary function. So y is equal to c1 e raised power minus x plus c2 e raised power minus 2x plus e raised power x out, then minus x by 10 cos x minus sin x minus 1 by 25 sin x, then it is plus 1 by 10 cos x. This we have found out the particular integral and solution of the given when it involved product of three functions, x, e raised power x, sin x. When it involves exponential function, you apply what? Rule number 4th. And when you did apply rule number 4, then we have reached to rule number 5, and we applied in I1, finding out I1 rule number 5, then we use it here in alpha. We have got the particular integral. This was also one of the typical problems that I have shared with you. I hope you will do the other problems. Almost we have discussed all the rules for finding out the particular integral rule from rule number 1 to rule number 5. I will share one or two questions more where you have the x, not this linear. You have say x square cos 2x, x square sin x. How you tackle those questions, you will do them by the rule number 4th, and after that we will be doing homogeneous this differential equations, which are also known as Cauchy-Euler equations. Thank you very much. See you next.